questions at the end. And if anyone's watching on the live stream and wants to submit questions, just tweet it at CodesCraft, and we'll try to make sure that they're answered. So, yeah.
Thanks for that. So hi, I'm Adrienne, and today I'm going to be talking about building better and smarter security warnings. So I travel a lot. I flew here from San Francisco yesterday, and I'm actually flying to, I think, Paris on Monday. And I love Google Now. Google Now is great when you're traveling. So here's a real example, which is 2 days ago. It tells me about the fact that I've got a Virgin America flight coming up. You click on the reminder, and it takes you to this Google Now card telling me all about my flight. It tells me whether it's on time or not. It has a link that takes me to the login, to the check-in page. And once I've checked in and had my boarding pass emailed to me, it even tells me, it'll just show it for me in Google Now, so I don't have to fumble around and try to look for it. And I love this. It's just magic. And in my opinion, this is this is a good example of great technology. Yeah, he's going to keep doing that. It's a good example of great technology. Just the right thing happens when I want it to. It helps me get the content I need, and it helps me move forwards. Now, let's contrast this with how many users experience security. So this is a real quote from a Chrome user who submitted a user report. I'm going to call this guy Jake. Jake says, "There's an error with some SSL. I don't understand. Help me, please." And that's rough. This is from about a year ago, and he was finding SSL errors all over the web. He was at work, and just all these websites he went to were giving him SSL errors. And as you can tell here, he was pretty frustrated about it and didn't know what to do. And that's not a great user experience. It's not a very magical user experience. And I'm sure many of you have probably experienced things like this yourself, too. I don't think Jake's alone. So here's one example. If you go to irs.gov to try to download some tax forms over HTTPS, you will be greeted with this lovely warning here. Or maybe you go to the shop and discover that this shop, for some reason that may not be clear to the user, is showing this warning. And this isn't limited to Chrome. I'm not picking up just on my own product here. Microsoft, Windows, Firefox, Internet Explorer, and Facebook here all have the same problem, which is they show you security warnings, and it's not always clear what you should do. Now, let me be clear. I'm not hating on security warnings here. They're actually really important. Security warnings are often the last line of defense between the user and an attack. Maybe that's malware, maybe that's phishing or some other form of social engineering, or maybe it's a network attack. I'm going to be running SSL. I'm going to be using SSL as a running example throughout this talk. And the reason we have SSL errors is to protect people from network attacks. A network attack is when someone between the client, your computer, and the server is trying to modify or view your HTTPS traffic. And these are real attacks that actually happen probably more often than people think. They range from, say, an internet service provider that's trying to insert advertisements into traffic to state-sponsored attacks that are targeted at a specific user. So these are things that really do happen, and we need these warnings. But that's not really how Jake is seeing it. From Jake's perspective, he's just trying to get something done, right? He's at work. He wants to get his report in so that he can go home at the end of the day and spend time with his family. He wants something that's more helpful. And I'm saying that it doesn't need to be that way. So we can build warnings that are more helpful, more actionable, and a little less frustrating for users when they experience this visible facet of security. So as Seth mentioned earlier, I'm on the Chrome security team. And one of the projects we've been working on is trying to make smarter warnings, meaning make our warnings more helpful, more actionable. And I'll go into that in a minute, what smart warnings really mean. But the goal here is just to help users when they're facing this situation. And throughout this talk, I'm going to use SSL as an example because that's just something that happens to be in progress right now. We've also been working on applying the same thing to other types of security UI in Chrome. So what does it mean to build a smart warning? Well, the first thing is that a smart warning, a helpful warning, suggests actions that you can take. It doesn't just say, oh my God, security thing happens. Right? Ideally, it should tell you what to do. It's easier to explain this with some examples. And by the way, this can apply to other types of errors too, not just security warnings. In fact, these two examples here are both from Chrome, but they aren't security specific. So in the first example, if you're offline in Chrome, you can click on the dinosaur and play this little game. And so you have something to do while you're offline. In this other example, I just intentionally mistyped a URL here. And at the bottom, it tells you, do you mean this other URL that actually does resolve to a valid host? Or it lets you search for that string on Google. These two different examples illustrate two different ways to go about making an actionable warning. The first way you can go about it is just by trying to reduce the pain. So the dinosaur example is just trying to make the situation a little more fun. Now, that's appropriate for the type of warning or error where there isn't really anything you can do to fix the situation. Right? All you can do is try to make it hurt a little less. So that's the case when you're disconnected from the internet because you're on a plane. That's also the case when, say, a user is facing a situation where they're trying to install a known malware executable. There honestly isn't really much the browser can do at that point except tell you that it's a malware executable, unfortunately. So our main goal there is to try to make that interaction less painful. I'm actually going to focus more on the second one, which is trying to help people fix it. So in some situations, we can actually identify the causes of errors and give users suggestions for how they can proceed. And that's appropriate for some types of errors, like SSL errors, where there may actually be actions you can take to resolve it. So, this is great. Yeah, OK, just make things actionable, right? It sounds so easy. It is a real engineering challenge, though, because in order for an error to be actionable, it has to be self-diagnostic, meaning it has to be able to actually figure out what's causing it. And then in addition to figuring out what's causing it, suggest ways to resolve the problem. And not only can this be challenging for errors where there are lots of possible different causes, but it can be challenging in security where, let's say we're trying to decide between a real attack and a misconfiguration. Attackers are adversarial. They're actually incentivized to try to make their real attacks look like misconfigurations. So you have to be very careful about how you go about doing this so that you don't actually accidentally make it easier for an attacker to launch their attack. Now here's an example of why this can be difficult in security. So this is a error showing a self-signed certificate. So normally, when you visit, say, google.com or etsy.com, and HTTPS is set up correctly, the browser validates the certificate chain that the server sends you. What this means is, more or less, that a central certificate authority vouches for the identity of the server that's presenting these credentials. So Chrome knows, oh, hey, I'm really talking to google.com. I'm not talking to some person on the network pretending to be google.com. Now, some developers choose to launch websites that don't actually have this sort of seal of approval from a certificate authority. Instead, they sign their own certificates. And so what this means is that from Chrome's perspective, can't tell if you're talking to google.com or some random attacker on the network. So unfortunately, there's not actually much we can do in this particular situation without making it easier for an attacker to launch an attack. Here's another example that's more difficult to diagnose from a policies perspective than a technical perspective. So this is a screenshot of a real user report we had from a woman who was trying to go to Facebook and instead was getting SSL errors, and she took a screenshot of the certificate viewer in Windows. And she was seeing a certificate from Wavecrest every time she went to Facebook.com. And I was on the help forum rotation that week, and I tried to help her out. And it turns out Wavecrest is not an attacker. They make software for schools and companies to do content filtering. So it turns out this person was a student and was seeing this error on the network at her school. Is this an attack, or is this a problem we should resolve? And if we resolve it, what do we tell the person to do? I assume from the school's perspective, this is not an attack. This is a totally legitimate thing that they feel that is well within their right to do. And in fact, in some jurisdictions, schools may even have legal requirements to do something like this. But from the student's perspective, to her, maybe she feels like this is an attack. So if it's not clear from a human perspective what we ought to be showing here, imagine trying to actually put that into code to categorize. With that being said, it's not actually a hopeless or impossible problem. So what I've found is that users are great at identifying root causes like this themselves, if you look in the help forums. So my team does a sort of informal help forum rotation now, where we go through the help forums, and we look at the types of problems people are having and how people are suggesting they resolve it. So it turns out when we started doing this, maybe 6 months ago, people had basically created a checklist. So someone would go into the forum and be like, I'm getting this error, what should I do? Some other user would respond, first, check your clock. Second, if you're in Windows XP, you need to upgrade because it doesn't support SHA-1. Third, try this other thing. So this is actually a pretty good list of tips. And so these are all very high impact things. And they're also things that we were able to either just completely resolve, say by supporting building in our own support for SHA-256 on Windows XP, or in some other ways that I'm about to show you. So as I mentioned, the top one that we saw was people having their clock set incorrectly. This came as a surprise to us. I wouldn't know why people would have their clock set incorrectly, especially when most operating systems offer the ability to automatically set it. So there are two reasons. One is CMOS battery dying. The second is games like, what's it called, Candy Crush. So you can get more prizes by it being tomorrow. Yeah, so first it's like one day, and then suddenly you're in 2016. And the browser doesn't know what to do because it looks like certificates are either not yet valid or expired. So from the browser's perspective, starts showing security errors. So what we did here is we implemented a heuristic where we can compare the current date to the build time of Chrome. If the current date is before the build time of Chrome, pretty good indication that there's a problem with the clock in the client. Similarly, because Chrome auto updates, and we have pretty good update uptake, if it's too far, if you're too far in the future, we think something else has gone wrong there. So in these cases, we show this new error, which is no longer a security error, but something meant to be more helpful, where we tell you your clock is either ahead or behind. We tell you what your current date is, and there's a big blue actionable button that takes you to your operating system's date and time settings to fix it. And in fact, we found out that this was causing 13% of all the SSL errors we were showing. So we've now replaced 13% of SSL warnings, going from being scary things to being this much more helpful, more useful type of error message. Here's another example. I see this one a lot. This is the one that engineers always complain about, which is captive portals, meaning Wi-Fi login. So you're in an airport or whatever, hotel, trying to connect to the Wi-Fi. And what these captive portals do is they try to redirect you to their login page. The way this is usually done generally ends up creating SSL errors. And a pretty big chunk of them, because we were seeing lots of user complaints about this. And this is actually a really inopportune time to be seeing SSL errors, because if you're on an unfamiliar Wi-Fi network, particularly in public, that's also a potentially dangerous place that you're in. So there could be real attacks happening there. So what Chrome does now is every time there's an SSL error, we delay showing it for 2 seconds. And during those 2 seconds, send a request to a known HTTP address. We know what we expect in response. If we get something different in response, and that response is pointing you to what looks like a login page, instead of showing an SSL error, we show this one, which tells you to connect to the network and tries to help you log in. So this error, by the way, is, I think, about to roll out with Chrome 42. So that's a few weeks away. And based on pre-release versions of Chrome, meaning Chrome Beta, Dev Channel, Canary Channel, we think that this is causing about 7% of errors. And of errors on big websites like YouTube and Google, I think even higher than that, maybe as high as 11 or 12% of that class of errors. So I'm pretty happy with how those two examples worked. But the problem is, once we nailed down those and a few other ones, we started getting to the long tail. So we started tracking other root causes that either we could think of or we found in the help forum. And as you can see here, none of them really make up a big chunk of anything. So one thing we thought was maybe a problem with, if you just type like say the certificate is for foo.com, and maybe there's a valid one for www.foo.com, we could tell people to add the www and go to this version of the site instead. But unfortunately, as you can see, it is kind of a long tail. There are these really big things that were causing lots of errors. And from here on out, we think each subsequent one is going to be pretty small. And also, there's still a huge number of errors that we aren't able to diagnose yet. And I'm going to talk to you now about how we're trying to approach those ones that we can't find the root cause of yet. All right, so we made it pretty far about, I think we now handle a little over 20% of all SSL errors, and in this more actionable way. So to progress forwards, we're asking users to send us reports of diagnostic data that we can use at scale to try to figure out what the causes are. So when a user sends you a report, it's usually a screenshot or a complaint. It doesn't have all the information that either an engineer or a heuristic needs to actually determine what's going on. So you may have seen this program before on our malware warnings, where at the bottom there's a checkbox. If you check the checkbox, it uploads an incident report to Google, specifically Google Safe Browsing, which is used to improve the accuracy of safe browsing warnings in the future. So we're working, actually, it's in the process of rolling out now, on implementing something similar for SSL warnings, where when users check a checkbox at the bottom of the SSL warning, it'll upload a report about, with information like the certificate chain that was delivered from the server and the certificate chain that the client built. Now, our plan is to do two main things with them. First, we want to cluster reports by common client features. So things like the type of, maybe there's an antivirus software program that's malfunctioning and causing this type of error on all the clients that have it installed. Or, maybe it's that a certain operating system is having some trouble with their root store. We're not sure exactly what we're looking for, but we're hoping we're going to be able to find it by looking at various different features of the certificate chains and the clients themselves to cluster in this manner. Oh, and let me mention one thing. So this is actually the really nice category of error, right? Because these are problems on the client, which means that users can fix them. In contrast, this is the hard part, right? If we identify problems with actually the server, meaning the web developer didn't configure it correctly, we have nothing we can really tell the user. There's nothing actionable there. Instead, what we have to do is reach out to the developer and try to get the developer to fix the misconfiguration. And the reason we can't downgrade the warning to say, oh, we think this is a misconfiguration, is because of what I just said earlier about it accidentally making attacks easier to launch. But nonetheless, we do want to know what types of errors developers are making so we can help developers stop making these mistakes. So we want to compare what clients are seeing as invalid certificates to what the crawler sees. If both the crawler, the Google crawler, and clients are seeing the same type of error on the same host name, it probably means that the site actually is misconfigured. And we'll make an attempt to reach out to the developer to get them to fix it, targeting websites with large numbers of users. So in conclusion, I really urge people who are building, other people who are building warnings and errors to look into this too, to see if you can also build self-diagnostic errors and warnings. Because we found that we could have a huge impact. We could resolve over 20% of them just by looking in the help forums, finding out what the common causes are, and then addressing those and making the warning more actionable. And we're hoping now to conquer the longer end with more client data. But making a warning actionable on its own isn't quite enough. There are two reasons why. The first is that sometimes either it just really looks like an attack, or there is nothing the user can do to resolve it. And in that case, we can't provide the user with a specific action except go back to safety. Don't do this thing. We just want to convince them to not do this thing. And also there are scenarios in which we do have an action, like we want you to fix your clock. But if we present you with 6 different actions on the screen, you're not going to know which one to take and might do none of them. You might end up just as frustrated as if we hadn't suggested anything at all. So we've been looking at different ways to help nudge users to take the action that we think is safest or best for them in the current situation. And we're doing this by following a technique called opinionated design, which my coworker Alex Ainsley is responsible for defining within our team. So there are three things that make up an opinionated design. The first is that it should provide clear instruction. The second is that the preferred choice should be very attractive. And the third is that the alternatives should be unattractive. Basically, it should be just by looking, without even reading, just by looking at the warning or the error, you should be able to tell what Chrome is recommending. And that should help undecided users or users who are struggling to figure what to do. So here's an old example. This is an unopinionated warning. This is our older SSL error design. There are a few things I'd like to point out. The first is that it did give a clear instruction. It told you you should not proceed, especially if you've never seen this warning before for this site. So, it does have that. It was at the ends of a very long paragraph, so I'm not sure how many people actually read that far, but nonetheless, it does try. But then the two options of proceeding anyway and back to safety are presented with equal weight. They look very similar. Chrome isn't saying, you should go back to safety here. It's just saying, hey, you got a choice. Do whatever you want. So here, although there was a clear instruction, it's still not particularly opinionated. We're not nudging an undecided user in any particular direction. So in contrast, here's the newer design, which was designed to try to convey an opinion. The first thing I'd like to point out is that the back to safety button is pretty prominent here. It's large, it's blue, and it's intentionally designed to look like the primary action buttons in many Google properties. Like if you've ever used Google Docs, there's a big blue share button in the corner. It looks very similar to this, actually. Now, if you want to take the choice we don't recommend, and we use the same one, by the way, for getting people to fix the clock or suggesting that they log in. We use the same blue styling. Now, if you want to do the action that we don't recommend, you have to click on Advanced, and then click on a link that says Proceed to Wherever and is labeled pretty prominently Unsafe next to it. So I think we're making it pretty clear here that we don't want you to do this. Like, it's smaller, it's gray, and it says unsafe in words directly next to it. So we feel like this fulfills the guidelines of opinionated design pretty well. But don't take our word for it. We've thought this before, and it is important. So I think one of the problems that we've seen in the security field with design in the past is that people tended to build designs based on conjecture and then not do testing to actually confirm that their gut feelings about what people thought or what people wanted was correct. And this is particularly problematic when you're designing for a very broad audience. Not everyone is a security expert. So if a security expert is designing a warning that appeals to them, it may not translate well to the rest of the population, which, and Chrome has a very broad user base. So we now try to make a concerted effort anytime we make a significant design change to do A/B testing. Now, some people find it surprising that we have the ability to do A/B testing in Chrome because it's generally associated with web properties, not with native applications. One of the things I really like about working on Chrome is that we do have a nice A/B testing platform. So I don't know if any of you run Chrome Canary or the Chrome Dev channel, but that's where you often encounter A/B experiments, and in fact, that's where we ran this A/B test. So the first condition we looked at was the old, less opinionated version, and we compared it to the new, more opinionated version. With that being said, we also changed text between the unopinionated and the opinionated. We had in parallel an effort to make the warning text more understandable because in lab studies, people were telling us that they thought the SSL warning was about phishing, and that concerned us. We wanted to make the threat more clear. So we did update the text at the same time. So to control for that, we have this middle condition, which is the old design and the new text. So that we'd be able to see if it was the text or the design that affected a change. So here are the results. We here have a sample of about 4,000 people in each condition. And adherence in this situation means is the inverse of the click-through rate, meaning how many people took the action we wanted them to take. So you want a high number here. So as you can see, the old warning had an adherence rate of about 30%. And the new, more opinionated one has an adherence rate of 58%. So it's almost twice that, and as you can see, it wasn't responsible to text. It really was a design change. So with a not even huge design change, we've doubled the rate at which people take the action that we're preferring. And that's pretty significant. And we originally were crossing our fingers thinking, oh, maybe it's just that it looks newer. I thought, oh, surely you'll see adherence drop down as people get accustomed to the way it looks. But that actually hasn't happened. I think, let's see, we ran this experiment last summer. So it's been unstable for more than 6 months now. And adherence is currently holding at 62%. So that's a lot higher than it was before when it was at 30%. And we're not the only ones who use this type of technique. We've seen this a lot before in other domains. So for example here, I coincidentally saw this yesterday. This is the Los Angeles Times asking you whether you want to sign up for something. And as you'll notice, the preferred action sign up is a nice juicy blue button, whereas no thanks is not quite as clickable. So given the fact that they're doing this, my guess is that this type of design technique is actually pretty useful in other fields as well. And maybe the security field's a little bit behind, that we're just starting to do this now. But it seems to be working for us. So if you yourself are ever working on an error or a warning, I'm actually thrilled with how it's turned out that we've adopted opinionated design techniques. And in fact, we've done similar things with some of our other warnings, in some cases increasing the adherence rate as high as 95%, just based on making the design more opinionated. So let's briefly revisit Jake, because Jake's sadness makes me sad. It's my hope that with these changes we're making, of making warnings more helpful, more actionable, and more opinionated, the next time Jake sees an SSL warning, he'll have a better idea of what to do and how to resolve the problem. My guess is that there's still many cases right now where he's going to end up frustrated, but I'm hoping that, say, a year from now, that's changed and that there are far fewer people like Jake. So to recap, the two techniques that I've talked about today are first to build smart errors that suggest actions via self-diagnostics. And again, I loved working with the help forums. It gives you a lot of insight, even though honestly it is a little bit painful. And second is to use design to clearly convey the opinion that you want the user to take away with them. All right, so thank you all very much for listening. I think I can take questions now, but also, if you have questions later, you can email me at felt@chromium.org. And also, this has been a big engineering and design project. So my teammates also deserve credit, particularly Alex Ainsley, the designer who we've been working with. Thank you.
Hi, thank you for such a great presentation. Lots of interesting stuff to think about. I was wondering, so when you talked about the breadth of how many different kinds of users Chrome has, I was wondering if you could talk a little bit about whether your team does any kind of user persona work or uses user personas, and maybe what some of the axes that differentiate different kinds of users are and how that affects what you could put into the design of security warning. For instance, I'm curious about how localization and people with less fluency in English or whatever written language you're using influence this.
Okay, that's a great question. There are actually maybe a few parts of it that I'm going to address separately. The first is personas. So we didn't actually start off doing any persona-driven work, so this actually wasn't persona-driven. But lately, we've been thinking more about personas. So for some other work we're doing, for example, we're thinking of 3 types of users. One being a very privacy-concerned user. And on the other end, having the privacy-unconcerned user. And then in the middle, the privacy-pragmatist, who will maybe make trade-offs. And there are different traits of these 3 groups. One thing that we try not to do is segregate people based on level of technical fluency, because we don't want to end up making a system that works very well for people with high technical skill and doesn't work very well for people with low technical skill. So we try to focus on how much they are concerned about security or privacy. I think you also mentioned something about localization. And localization is actually something that I'm a little embarrassed about. All of the studies we ran were ran in English. We We focused on the US, Canada, and the UK. And that was partly because of the difficulty of running studies in other languages. And you also run into the problem where you don't know if, say, people in Spain are reacting differently than in the US. You don't know if that's a cultural difference or a difference in how the translation was done. With that being said, I think this is something that I'm not quite comfortable with how US-centric our studies have been thus far, and it's something I'd like to see us address in the future.
Hi. Does your team worry at all about attackers imitating these error screens and calls to action and sort of like tricking users into doing malicious actions? And is there anything to do about that?
That's also a great question. Yes, I am definitely worried about it because we see it happen really fast, too. So you can sometimes see a turnaround time between the real warning launching and social engineering in like 2 or 3 weeks. I take this as a form of flattery that I have fans who follow my work. But no, seriously, it is a real problem, especially when you have like a malware warning, and let's say you do click through it. Now you have this other malware warning, and this one's giving you a phone number to call, and they're totally going to help you with the virus on your computer if you call them and tell them your password. So it is something we're struggling with. One solution is to try to make it more clear that the real warnings are tied to the browser Chrome and aren't just in the content. But we haven't figured out a great way to actually do that yet, and it's particularly challenging on mobile. Say you have something like a web view, where we show our errors in web views, and it's all content, there's no Chrome. So I wish I had a better answer for that.
Hey, first I want to do this and say magic. Second, do you know if there are similar teams at the other browser vendors doing this work, and how open are you to sharing your data with those teams?
Fun fact, the Chrome and Firefox offices in San Francisco are in the same building.
I used to work for Firefox.
So we do talk with the Firefox team pretty regularly. They have some great people. In fact, they were super nice to us. We saw that, so our adherence rates were about 30%, and theirs were about, I think, 60%. Right? So their warning was doing a lot better, and we were curious why. So we wanted to know if it was a difference in design or a difference in user population. So they gave us permission. I actually built their warning in Chrome, looked just like it, except with a string saying Chrome instead of Firefox. And we ran that as an experiment on some Chrome users to see if people would respond better to the design. And it was interesting because it turns out their warning was a little bit better than ours, but there was still a pretty big gap, which told us that there was some other factor, like maybe demographics, that was affecting how Chrome users were responding to warnings. And so maybe we would need to use some different techniques than what Firefox was doing to reach our own users. So there are people at Mozilla who are working on this also.
Hi. So you mentioned demographics a couple of times. I'm curious because do you run these A/B tests in release ever, or is there some adjustment for sort of self-selection people who choose to run an area or beta versus?
I'm sure there is self-selection. We do see differences in user behavior between, say, Canary and Stable. With that being said, you can run A/B tests on Stable as long as it's ethical to do so. And in this case, because we saw how huge the difference was on Canary and Dev, I actually thought it would be unethical to intentionally delay the release of the better warning just to do an experiment. So we ended up just launching everyone on Stable instead of doing an experiment. And then we just saw that during you can see in the transition, in the week of the transition, how people are reacting and get confirmation that they're reacting the right way. And if people in Stable had reacted poorly, we could have, from the server side, pulled it back if we needed to.
Have you considered making that segmentation something that's adaptive, so that after a browser's rolled out, it uses some heuristics to work out how pragmatic or cautious somebody is, and issue the most appropriate warning?
I would love to do that, and I'll be honest, I don't know how to. There are two challenges. One is I don't want Chrome to become creepy. Which is a real risk, right? If personalization can be creepy if it's unexpected. The second challenge is you don't want to accidentally sort of sort someone into the wrong bucket and take away choice that they maybe otherwise would have used, because that would be a negative outcome. And third is I actually just don't know how to do it. Like, I don't know how to tell which group someone's in without talking to them. And I don't know if there are any user researchers in the audience, but if you have bright ideas about how to do this, or do work in this area, I'd love to hear about it.
Sort of riffing off of that, who are the attackers? Is there any sort of like change in advisement based off of who those attackers are?
Yeah, that's a hard question to answer. So the attackers can be many people. It can entirely depend on your perspective, right? The attacker may be your employer, who would not consider themselves your attacker, but maybe you think they are. Maybe you don't have the best relationship with your boss. Maybe you don't want your boss to see what you're doing online. In some cases, it might be your government. And people have that's a very political topic, right? People have very different opinions about governments and what they have a right to do or not to do. It could be an ISP who has found a new way to monetize. I don't know if we have a way to tell the attacker apart automatically for the user. I also don't know, we have to be careful to not make it it's hard enough to tell the difference between an attacker and sort of a legitimate use case, and a misconfiguration. And I don't know if we could dive deeper into that and tell attackers apart from each other. I'm not sure how that would work, but I do think if we had a way somehow to know this, I do think people would react differently to, hey, we think this is an ISP changing advertisements, and we know that you're a gay rights activist in this country, and we know that your government may actively be trying to find you and your friends and hurt you. I wish we had a way to know that.
Hi. As far as the other prior tool has, as a user interact with it from like Gmail within your phone, did you integrate security warnings and errors and messaging within these other like cross-platform products that you have within Chrome?
Yeah, that's a good question. We have not yet made a concerted effort to do an audit of all the other security UI surfaces in other Google products at present. With that being said, we are converging in some things. So for example, I think search may now use the same strings, so search results will tell you if there's a problem with a page. I believe they now use the same strings as Chrome, and we are sharing in this way, but we haven't made a concerted effort to go everywhere and make it identical yet.
You talked about having things that are opinionated. How do you feel about ambiguity? Like if you have two options that are equally weighted, what would you prefer to do? Or what warnings would you prefer to give?
I have to say we haven't come across that yet. We actually try to avoid that situation, honestly, because I don't think people necessarily want to always be having to sit down and really think about a decision. So it's better if we can have an opinion. But with that being said, there are places in security UI where that does happen. So say, for example, you go to a website and it asks for the ability to send geolocation. That's completely up to the user as to whether the answer is yes or no. We do not actually really have an opinion there. To be fair, we do color the yes and the no answers differently, but they're given fairly equal weighting. We don't make it hard for people to say, we don't intentionally make it hard for people to say no to that. And this is actually, I think, one of the things that makes that space very challenging, is that we don't have a good opinion.
One really tiny thing. So the captive portals and how you now send in the background a ping to a known HTTP site, not as encrypted. What site is it? Because when I'm talking with other hackers, sometimes we're like, so what's your HTTP site that you go to at the captive portal? Because all the other stuff you go to is HTTPS. But like, write about a hotel, I have to go to BBC News to log in.
We have our own. It's, I think, gstatic.com/generate204. You can go there if you want.
Something you can follow.
Yeah. With that being said, you sort of hit on something a little interesting, which is that the site we ping is HTTP, which means an attacker can control it and send it to whatever they want. So if it is an attacker, they can make the login page be a bad page. With that being said, if a network attacker can do this anyway without our warning, because we already support captive portal detection, and if you're getting, like, say you go to an HTTP site and log in that way, you're still going to end up hosted by this captive portal. So I don't think we've introduced any new risk here. And maybe even help the situation, because currently, if say you go to gmail.com on a captive portal, then you click through the warning in order to get to the website, to get to the login page, I mean, you've now made an exception in the browser that associates that certificate chain with Gmail. And so you might even still continue to be hosed in the future. So I think it's an improvement, but it is a tricky bit.
Hi. I was wondering, in the screenshot where you showed how successful the new version had been against the older versions, I wondered whether you iterated on and tested different variations of that new design, because for that person, what his name, Nick or whatever, who's like encountering that error that is still that, go back to safety or like do something dangerous, he still might feel like frustrated because he doesn't understand what's happening.
Yeah, it's completely true. Making it more opinionated without making it more actionable doesn't really help, right? Well, it helps a little bit, but it doesn't get you out of that situation where you're seeing misconfigurations all over the internet and have no idea why. So just making it more opinionated doesn't solve that problem, which is why we're putting like a huge amount of engineering effort into trying to make them more actionable as well. With that being said, I think in a lot of I think in many cases, we are going to have to take out-of-band measures to try to get developers and software vendors to fix the fact that they're doing misconfigurations. So not all of the things we are finding are things that we can provide to people as actions, which is a little bit frustrating for us because we would like to be able to tell people how to fix it, but often we can't. We have to figure out some other way to reach out to fix the problem. But we did test others, though.
Hey, what percentage of Chrome users send their diagnostic information to Google?
I don't remember off the top of my head. I mean, it's not everyone, and that's fine. What? Well, we can tell from the number of reports we get that not every Chrome user is sending us reports, and that's okay. We have a big enough user base that even if it's a fairly small percentage of users, we still get enough reports to help improve our warnings.
Did you find that depending on whether it was a mobile device or a laptop or desktop, that that sort of influenced any of this at all? Because generally you'll hear people say, "Oh, well, a mobile device, so can it might be watched, so it's safe." Did you find that all influenced this?
Yes, we do actually see different adherence rates on different platforms and different operating systems. There's a few things at play here. One is that even among desktops, people act differently on Linux, Mac, and Windows. If I remember correctly, Linux users and Mac users are more likely to act riskily, even in situations like SSL, because they think their operating system is going to protect them, even when the threat is on the network. Yeah. I mean, to be fair, right? People don't really get viruses on Linux, whereas on Windows, people are more likely to have had a negative experience in the past. And so maybe they're going to be more cautious, right? They've been burned, they've learned, whereas people on other operating systems may not be having that experience. So even within desktop, you see different behaviors. With that being said, so we do see, I think, people on Android are very slightly more conservative. But it's hard to know if that's an operating system difference or a form factor difference.
so much to Adrienne Porter Felt.